That's absolutely amazing. I do
Yeah.
want to talk to you about ketones and supplementation, who should be taking exogenous, who could be thinking about that. I think we're learning more and more about, the cycling teams that are buying them up in
Yeah.
preparation for races like the Tour de France. I know you guys have had application in ice hockey. Those are two of my favorite sports anyway. So
Mhm.
that's all amazing. So let's come back to that. But we do have to point out to the listener, obviously, if you haven't come across Dom's work, you've been living under a rock. This is not a person that just found the keto diet and put out a cookbook like last year and started an Instagram page. You have been into this for a very long time. I remember when I first started getting into this, it was some of your content and your interviews and podcasts that I came across that really helped me understand what the hell any of this was. So for the listener, can you tell them who you are and how you got interested in researching ketones?
Yeah. It was kind of like a slow process. Background in nutrition and biology, and I was always interested in different types of diets, even clinically. That's why I went to a nutrition science program, registered dietitian program, but I didn't do the clinical aspect and just double majored in biology. Then I went into neuroscience and got very interested in brain energy metabolism as it relates to extreme environments. And my primary focus was actually really on lactate. I wanted to see use lactate in the context of hypoxic brain injury to like re-energize. And I'm still interested in that and still, tinkering with things in the lab on that front. But then, as I was funded by the Office of Navy Research to be able to predict and mitigate central nervous system oxygen toxicity, which manifests as a grand mal seizure or tonic-clonic seizure. And in the process of exploring different mitigation strategies to enhance the warfighter, and oxygen toxicity is the main limitation for Navy SEALs that use a closed circuit rebreather. So it was kind of serving that aspect of our military, special operations community. I was mostly focused on drugs and various like supplements, antioxidant formulations, and things like that. And then this idea that the therapeutic ketosis worked remarkably well for seizures independent of the etiology, which means like you put someone on a ketogenic diet, you put them into therapeutic ketosis, and then it works for Lennox-Gastaut syndrome, temporal lobe epilepsy, all different types of seizures. So uh, my original idea was to use the ketogenic diet. The military said, well, come up with the ketogenic diet in a pill. So I think it was like 2007 or 8 that I, started tinkering with different formulations that could induce and sustain what we call therapeutic ketosis, which is the rapid elevation of ketones in the blood and to the brain, and to sustain that for a period of time that would be the duration of a Navy SEAL operation, or military procedure. So that sent me on a cascade of, experimenting with a bunch of different molecules. And actually, the beta hydroxybutyrate monoester did not work in our hands. So it actually sent us down the road to look at various formulations that elevate beta hydroxybutyrate and acetoacetate, and we are very agnostic as to like particular companies are kind of like very focused on one formulation that they have a patent to or whatever. So we're a bit different in that we work with dozens of different molecules, and we're just interested in the formulation that works for specific applications. So something that works, for seizures is going to be different than for brain injury, or for cancer or for other things. So we tend to diversify our portfolio of ketogenic agents, based upon the context of what we're studying.
Wow.
That
Well,
could, many different things, even
that
cancer.
wow. Yeah, that's amazing. Well, thank God you took that nutrition course, and studied that, because you must have had class after class after class of this wonderful metabolic state that we can get into as humans, and probably our normal state. I'm sure you guys talk a lot about that in your nutrition education. Is that correct?
Man, like nutrition education is great. It gives you a background, for example, on like vitamin K and what, niacin does, and vitamin B6. So it's really like uh it's really like nutritional biochemistry. So I took advanced biochemistry 1 and 2 and advanced nutrition 1 and 2, which were graduate level courses I took as an undergrad, was like advanced biochemistry, but in the context of, for example, micronutrients and, vitamins, minerals. And then, we delved into all the different, nutritional diseases from, beriberi to, kwashiorkor, like, protein deficiency, things like that. So it gives you a good foundation, but we didn't learn anything about low carb diets. I mean, there was really no discussion about nutritional therapeutic interventions that could, be used to treat the main problems that we have in the world, which is obesity. I mean, it was all about calories in, calories out, which there is a place for that, and that's 80 to 90% of but there was no discussion about different types of diets that could help one achieve satiation and help one achieve, glycemic control and things like that. There was a big stigma towards low carb diets, ketogenic diets. So they were just mentioned kind of in passing as a fad diet. I think, for our neurological, section, we did briefly talk about the ketogenic diet being used as a very last resort for drug refractory pediatric epilepsy. And at the time, in the early 1990s, when I was, in college, there wasn't a whole lot. People just the ketogenic diet wasn't on people's radar. It was just in the back of a neurology book for pediatric epilepsy.
Yeah, and if you understand history, you understand why like it wasn't that big of a deal in the 90s. But it's kind of interesting to lament that that research is not new. Like we knew 100 years ago the stuff about epilepsy and the stuff about seizures, but again, understanding the history of how we kind of went the
Yeah.
direction of pharmacology, or how a lot of the science that was being done in Germany was kind of lost in translation as things shifted over to America after World War II. But yeah, like I said, it's not like any of this stuff is new. I'm a nutrition coach, which is way low level compared to the research that you've done. And my 600 700 page nutrition book behind me has one sentence that even mentions ketogenesis happens when you burn fat. So kind of sad that the information isn't out there. You had this really amazing opportunity to do so much research in so many different fields. You mentioned Navy SEALs. What have been some of your favorite things to work on if you look back on your career and all the amazing opportunities you've had to do research around ketogenic diet for many different applications?
Yeah, good question. We're motivated by translational research. So a lot of research is done from like the bottom up, which means like you identify a mechanism and then work on that mechanism and try to figure out, a therapeutic strategy to employ whatever molecule you develop or, method you develop for particular disorders, right? So we were of the opinion it's like we knew the ketogenic diet worked and it worked remarkably well in the context of very powerful seizures. So then the question came out, well, how is it actually preventing the brain from going into a seizure? So it's doing that through a lot of different mechanisms working in synergy. So it's providing the brain a source of energy that the brain can maintain ATP levels even in the context of oxidative stress, which in this case is very, very high levels of oxygen that make a big burst of oxygen-free radicals or reactive oxygen species. So there's that, but it's also has an anti-inflammatory effect. It has like epigenetic effects, which I have a PhD student studying right now. It changes the neuropharmacology of the brain, and it allows the brain by altering different enzymatic systems, including glutamic acid decarboxylase, which is an enzyme that converts glutamate to GABA. It can shift the pharmacology of the brain. So as we started studying the diet, then we started applying it to different applications that could be genetic disorders like Angelman syndrome to inborn errors of metabolism, like glucose transporter type 1 deficiency syndrome. And then I had a PhD student come along who's Dr. Angela Poff, and she's my co-host for the Metabolic Health Summit. Uh,
Amazing.
and, she had an interest in cancer. So we started studying this and we've published about a half dozen, articles on, and, peer-reviewed science on using therapeutic ketosis as a means to reduce the growth and spread of cancer, metastatic cancer. And I think it has the best application for brain cancer because you have the dual use of it controlling the seizures associated with brain cancer, but also it inhibits it hits a variety of different mechanisms from suppressing insulin, elevating ketones, which have anti-cancer effect, to lowering glucose availability, to reducing inflammation, to having epigenetic effects that can alter gene expression and have anti-cancer effects through that mechanism. So it's working through many different mechanisms in synergy. And so I think the cancer stuff really surprised me because as I got into this, I was laser focused on the primary application of ketosis, the accepted application, which is seizures. And then it brought us down into different areas of science, including cancer biology and even the metabolic control of epigenetic regulation, which we're really delving into now. Uh, and I do believe that there's so much that we can learn from not only ketones as an energy metabolite, but ketones being produced in ways that alter specific enzymes that impact our gene expression and are called histone deacetylase enzymes, right? So they can alter different histone deacetylase enzymes, but the ketones can also directly impact gene expression by interacting with the histone, which actually plays a big role in gene expression. And I know that's getting way down into the weeds, but I think it's opening up a whole new area of science that I thought I otherwise would not get into. And I have to actually go back to my molecular biology books because my students are molecular biologists by undergraduate training, and I have to go back and to my old textbooks to just or new textbooks to keep up with
Wow.
some of the new science that's coming out on this. So that has been fun, and it kind of lends itself to this idea that if you get into a state of therapeutic ketosis, you can change your gene expression, that we are not, we're not kind of a slave to our genome, and that we can alter our metabolic physiology to impact gene expression in ways that have favorable health outcomes. And that could be from a cardiovascular, from age-related dementia to even to have anti-cancer effects through impacting gene expression. And I think this is a very rapid emerging area of science. And I think the metabolic control of epigenetic regulation, we're at the cusp of understanding how these metabolites, and probably not just ketones, it's lactate, it's various intermediates can really profoundly alter. And even pharmaceutical companies are looking at some of these metabolites and then trying to kind of like reverse engineer molecules that could be epigenetic regulators and that could be used for cancer therapies and for different disorders. So that has been very exciting because it keeps me like right on the edge, the bleeding edge of the latest molecular biology. And I have to work hard to really keep up with the science.